In this video, we're going to be looking at integration by substitution. So we're going to be integrating. We're going to be looking at the fundamental thermal calculus, but some of the problems are going to be a little more complicated. They're going to look ugly, but in reality, what we're going to do is we're going to transform them into something a lot simpler. All right? So what's the objective for this video? You got to be able to look at an integral, and within that integral, you're going to have to determine which part of that integrand is going to be the u and what part is going to be the du when you're using integration by substitution. And after you realize and convert it to using the u's, you're going to have to apply the fundamental theorem of calculus. All right, but first by using substitution. Okay, so this is what integration by substitution means. Sometimes you will look at an integral that looks complicated, okay, if you keep it in that form. However, sometimes the integral is really going to be the chain rule inside that problem. So a function is going to look something like this. It's going to look like the integral of f of g of x times g prime of x dx. So this is going to look complicated, and what we're going to do is we're going to identify my u to be g of x. So then when I take the derivative, like differentials, I take the derivative of u is going to give me du, and then when I take the derivative of this side with respect to x, is going to give me g prime of x dx. So when I do my substitution, this ugly looking integral, that monster, is going to become the integral of f of u du. And now we integrate it using the fundamental theorem of calculus. We find the antiderivative, but when we get our solution, we have to make sure that we convert it back into the original variable that we had. So we started with x's, convert them to u's, integrated, and then go back to x's. Okay, so what are the guidelines? Let's go ahead and look at the strategy for trying to integrate by substitution. What you have to do is you got to look at an integral and find, is there a g of x inside that problem? And the g of x can usually be whatever is in parentheses, but then the du might also be in parentheses. So you want g of x to be the one whose derivative will be there. It's also found under the radical, or sometimes it might be the whole exponent, or sometimes it'll be the denominator. And but you'll never find the du in the numerator, okay, unless the denominator happens to be just a constant. Okay, so the du will never be in the denominator. The u will, but not the du. Once the u is identified, you must take the derivative in order to find the du. And what we do now is we convert it back, the u's and du's, into the integral. Okay, so then we integrate it, and then we bring back the original variable. So what we got to do is we first have to be able to identify the u in each problem. So when I look at this problem, you're going to say, sir, what is my u going to be? Remember, you're going to pick something whose derivative is also going to be there. So in this case, in the first example, I see parentheses here, and this angle here, the 5x, is going to be my u. Now, what's the derivative of 5x? The derivative of 5x is going to be 5 dx. And if you notice, the 5 dx is present right there. So what I'll do is I'll use a circle for my u, and I'll use a box for my dx. So then I look at the next one. The next one here, ooh, this is an easy one because I see a radical. So usually it's what's under the radical. So right here I have an x squared plus 7. So before I put it over here, I just make sure that I take the derivative of x squared plus 7, which is 2x, and then I see it there. So my u is going to be x squared plus 7, and my du is going to be 2x dx. So my box, this is part of my box right here, and this is part of my box. So now this problem becomes the integral of the square root of u du. And this one up here, the top one, example number 1, becomes the integral of secant squared of u du. And of course, you know that the derivative of tan is secant squared. And here I have u to the 1/2, so it's going to become u to the 3/2, multiplied by 2/3. On the next example, remember we said for some unknown reason, the 4 did not come out right here. There was supposed to be a 4 right there. Okay. I told you that the du will never be in the denominator. So you don't want to pick the u to be my numerator. You want the u to be my denominator. So I'm going to say that my u is going to be sine of x plus 4x. Now, what's the derivative of sine of x? Well, the derivative of sine of x is cosine of x, and the derivative of 4x is going to be 4. And let's not forget to put the dx, because we're taking the derivative of each side. So some of you might say, what are you talking about? So u is going to equal to sine of x plus 4x. So I'm going to take the derivative of this, like differentials. So the derivative of u is going to be a du, because I took the derivative of this side with respect to u. But this side is a different variable. So I'm going to take the derivative of this with respect to x. So I'm going to say cosine of x plus 4. But then I'm going to tell you that on this side I took the derivative with respect to x. Okay? So now example number 3, this ugly monster is going to be transformed into this easy baby problem. So I'm going to have a du there, and I'm going to have u there. And the integral of 1 over u du is going to be the ln of the absolute value of u. Okay? So you're saying, oh my gosh, this is not that hard. So we look at this one here on number 4. Now, is my u going to be the 3x squared? Is it going to be the 3x squared plus 7, or is it going to be the x cubed plus 7x? And what you want to do is you want to pick the one whose derivative is the other. So in this case, on example number 4, I'm going to choose x cubed plus 7x to be my u. And then when I take the derivative of this, I'm going to end up with 3x squared plus 7 dx. That'll be my du. Okay? So now this problem is transformed into the integral of e to the u du. This is part of my box, and this is part of my box, and this is my circle here. Now, did you notice that the e is not circled? Because it's not part of my u here. So therefore, my problem is going to be e to the u du. And the integral of e to the u is e to the u plus c. We got one more to go. Okay, so let's try this one here. Which one is which here? See, the derivative of 40x to the 4th is 160x to the 3rd. Nope, that's not it. The derivative of 8x to the 5th is 40x to the 4th. Oh, I see it now. So this here is going to be my u. So in this scenario, I'm going to have 8x to the 5th minus ln of x. And did you notice that I didn't circle the 3? Okay. And then this is part of my derivative, that with that. So the derivative of that is going to be 40x to the 4th minus 1 over x dx. So this is my du. So this monster is going to become the integral of u to the 3rd du. And this becomes really easy, and the integral of u to the 3rd is u to the 4th over 4 plus c. Okay? Now, what about this example? Let's go ahead and try some of these out. All right. So on this example, I'm looking at it. I need to pick my u and then take the derivative to find my du. All right. So in this scenario, I'm going to choose this guy to be my u. So I'm going to have x squared plus 3x. Now the derivative of u is du, so the derivative of this side is going to be 2x plus 3. And let's not forget to put the dx. Okay? So now, this is part of my du, and this is part of my du. So I'm going to have the integral of u to the 8th du. Okay, now, here's what you need to understand. This is a definite integral. It's definite because it's defined at the bounds. So, if you want to, you can integrate it and leave it in terms of u. Okay, so this is method number 1. So I'm going to stick with method number 1. I'm going to show you the method, and then you're going to get to choose. I like to use method number 2. So now, because Quintana, this is x equals and this is x equals, now I got to convert them into u equals and u equals up here. So then that means that I'm going to take my 0. I'm going to take my 0, this 0 right here. I'm going to take it, because I'm trying to find out what it is. So and I'm going to insert it there, and I'm going to insert it there. So when I plug in a 0 here and a 0 here, I'm going to end up with 0. So it also happens to be 0 right there. So then the next thing is to plug in that 2. So I'm going to plug in that 2 there and plug in that 2 there. So I'm going to end up with 2 squared plus 6. That's 4 plus 6 is 10. So now this becomes a 10. You see how the bounds change? So now let's integrate it. If I integrate it, I'm going to get u to the 9 over 9 from 0 to 10. So when I plug in the top, I'm going to get 10 to the 9 over 9 minus 0 to the 9 over 9. So my answer is going to be 10 to the 9 over 9. And this is my answer. Okay? So now, what we're going to do is we're going to try method number 2. Method number 2, what we're going to do on this one is we're gonna still have the integral u to the 8th over, I'm sorry, u to the 8th du. But if you notice, I didn't put any bounds. So the integral of u to the 8th is u to the 9th over 9, right? And of course, I didn't put any bounds. What I'm going to do is I'm gonna bring back my u, and my u is going to be x squared plus 3x to the 9th over 9. Now I bring my bounds, my original bounds back, 0 and 2. So when I have this problem, I'm going to plug in my 2, and I'm going to get 2 squared plus 3 times 2 over 9 minus 0 squared plus 3 times 0 over 9, which is also going to give me 10 to the 9th over 9. So basically, you can do the substitution early and convert them, and then you just plug in those numbers, or you do the substitution here and then plug in the 2 and the 0. So it doesn't matter if you substitute them at the end or you substitute them at the beginning, you're still going to end up in the same results. Okay? But I like using method number 2. All right, in this scenario, they want me to find the integral from 0 to pi of this function. And if I notice, this looks almost like 0, so I better get 0 as an answer. In this problem, I'm going to pick my u to be sine of x plus 10. And the derivative of sine of x is going to be cosine of x, and the derivative of 10 is 0. So I'm done here. Now, if you notice, this problem has a negative. So I'm just going to leave that negative alone, or I'm gonna stick it outside. So I'm not gonna worry about that, the bounds, because I'm converting them to u's and du's. So I'm gonna have a u on the bottom and a du on top. Okay, because this right here is part of my box. This is part of my box, but this is part of my circle. Okay, so I'm gonna be left with that. And the integral of that is going to be negative ln of the absolute value of u. But sir, I don't put the bounds because I'm going to go back and change it back to my x's. Okay, so that now is going to be converted into, the ln of the absolute value. And what was my u? I bring back my u into this problem. I'm going to get sine of x plus 10 from 0 to pi. So I'm going to plug in a pi, and I'm going to get the ln of sine of pi plus 10. And then I'm going to get minus the ln of the absolute value of sine of 0 plus 10. Oops. And don't forget, I'm forgetting this negative out there. Put that negative there, put that negative there, and put that negative there. Okay? So I know that these two, the minus the negative becomes a plus here. Okay? So that's going to give me the ln, and the sine of pi is going to be 0 plus 10. Oops, don't forget that negative here in the front. Plus the ln of the sine of 0 is 0 plus 10. And that's going to give me negative ln of 10 plus the ln of 10, which gives me 0, and that works out. Now, here's the thing about this negative out here. I could forget about it, work this problem out, and then finally, at the very end, plug in the negative to my final answer. You could have done it that route. Okay. I wonder if I have another example. Yes, I do. Okay. Now, this one is the one that throws students off. Let me explain why. in my u, we know that it's going to be what's under the radical. So I'm going to say 3x squared plus 7 here. And the derivative of 3x squared plus 7 is going to be 6x dx. So when my students look at that and says, hey sir, right here I see my u, the dx is part of my box here, and I have the x, but sir, there's a 6 missing. So this is the one my students struggle on the exam. They see the x, they see the dx, but they're lacking the 6. But in mathematics, you're allowed to put a 6 as long as you put something that will cancel it. So I'm going to put a 1/6. The 6 on the bottom and the 6 there will reduce to a 1, and 1 times anything is anything. So now this problem is identical to what I had originally. So now it becomes 1/6 the integral of the square root of u du. All right, so that's going to give me 1/6 and the integral of u to the 1/2 du. Oops, I don't know what happened there. I don't know where that's coming from. U to the 1/2 du. Okay, so now this means u to the 3/2. You add 1 to my power and divide by its new power, or multiply by its reciprocal, times 1/6. Okay, plus c. Now remember, in the other video I said if they do not give you bounds, you have to put the plus c, because the derivative of this function better give me that function. And I could have any constant out there, and the derivative of the constant will be 0. So when I reduce this, I'm going to end up with 2/18 is really 1/9 u to the 3/2 plus c. Now if you give me this answer on an exam, you're going to get it points deducted. You did everything perfect, but you need to understand that my original problem had x's. So this is an unacceptable answer because I don't know what my u is in this problem. Your u could have been different. So the answer better be 1/9 3x squared plus 7 to the 3/2 plus c. And this is the correct answer. And I believe that's the last example that I have. Okay.